This is example 5-3. We're going to use a piezometer to measure the flow, right? So we have flow coming into this reduction here, and we have piezometers before and after this reduction, and we have measurements of HA and HB, and now we'll try and see what the flow rate is. So let's see. If we want to use Bernoulli, which of course this looks very much like a Bernoulli problem, then we'll have to have ideal fluid, which we have. We have water. So we have ideal fluid, again, that's incompressible and inviscid. We need to have steady flow. That is also given to us. Doesn't say anything about velocities changing. And we have to have points that are on the same streamline. So we're going to have our point A and our point B, and they're going to be connected by a streamline. So we're good there. So I'll just say same streamline. All right, that's all good, which means we can write our Bernoulli equation for point A at point B, right? So we know that the pressure at A divided by gamma plus the velocity at A squared over 2g plus the elevation at A has to be equal to the same at B. PB over gamma plus VB squared over 2g plus ZB. And now we can just go through and figure out, are there things that we know straight ahead, right? So what we want to do is we want to find either VA or VB, because we know what the cross sections are. So if we know what the velocity is and we know what the cross section is, then of course we know what the flow rate is, which is what we want to do. So first we can set our datum, right? We can say our datum goes, on that to the center of this this pipe. Throws that way. Our z's are both 0. Datum at center of pipe. That means ZA is equal to ZB is equal to 0. Of course, we could have chosen anywhere else. If we have chosen anywhere else, then ZA and ZB would be the same thing, and then they would just cancel out. So might as well set them to 0. Now, the other thing that we can see is that our pressure, our static pressure, of course, we can base on these piezometers, right? So we can say static pressure based on piezometer. I guess it's 2. So we can say PA is just gamma times HA. PB is gamma times HB. And we're given HA and HB, so we know what PA and PB are. All right, so now that's only that we're left now as unknowns are our velocities. Unfortunately, we have 2 velocities, VA and VB, but we only have one equation, so we'll have to come up with another equation. What other equation can we think of? Well, of course, we can think of this. We'll do this in a different color. Right? We can say this here could be our control volume, and then we can use continuity equation. Right? So we'd have an area vector going out here, an area vector going back there. We'd have velocity vectors. It's kind of hard to see. There and there. All right, so we can say, now can we use the continuity equation? Well, if we want to use the continuity equation, right, then we have to have steady flow. We already said we have steady flow. We need, or in our case, we have incompressible flow, so that's good. Because that means we can divide through by rho. We have incompressible fluid. We have a fixed control volume. And we can use average velocities. Right, so that makes our continuity equation much easier. Average velocities. What does that mean? Well, if I have an incompressible fluid, right, then there's not going to be any internal changes due to pressure. I also will have, like, the actual control volume is fixed, right? So that doesn't change. So my dV rho dt term is equal to 0. So we are left with 0 is equal to the ins and the outflows. Now at A, we have, I made a mistake there. That's of course not correct. My V is pointing in the wrong direction. Let's see if we can fix that real quick here. V should be in this direction, of course. There we go. All right, so I know at A, they're both in the same direction, so that'd be positive. So I'd have VA times AA, and then at B, it's negative times AB. All right, so this is all circular, so I have VA times pi over 4 DAA squared, not DAA, just DA squared, minus VB times pi over 4 DB squared. Because it's all equal to 0, I can divide by the 4 pi. So I can say VA times DA squared is equal to VB times DB squared. All right, and then let's solve this for VB, and then we can plug that into our Bernoulli equation. So we'd have VB is equal to dA squared over dB squared times VA. All right, so now with that, let's go back to our Bernoulli equation up here. What can we say? Well, let's just write it down. Right, so we have PA, we calculated was going to be, let's just write the whole thing down. Let's make it less confusing. Plus VA squared over 2G plus ZA is equal to PB over gamma plus VB squared over 2G plus ZB, right? That's just our regular Bernoulli equation. Now, we already said that ZA and ZB are equal to 0. So that's always good. We figured out that this is gamma times HA, and that this is gamma times HB. And then, of course, we just figured out what VB is, so we can plug that in as well. So what do we have? We have gamma times HA over gamma. VA is what we're looking for. Is equal to gamma times HB over gamma. Those, of course, are going to cancel. Now, our VB we set up here was dA squared over dB squared times VA. That all squared because it's a VB squared over 2G. All right, what do we see? We see, of course, that these gammas cancel. If these gammas cancel, then we can also cancel. Oh, we can't cancel those. The G's we have to leave, so maybe we'll rewrite this. So let's go back to blue. So we could say that VA squared over 2G minus, how do we write this? So this would be then dA to the 4th. Let's make that a 4, not some scribble. dA to the 4th over dB to the 4th times VA squared over 2G, right? That's just rewriting this one. And then on the other side, we'll just have, because all the gammas cancel, we have HB minus HA. All right, so what else can we do? We can go ahead and multiply this, or I guess we can pull out the VA squared over 2G, right? So we'd have VA squared over 2G 1 minus dA to the fourth over dB to the fourth is equal to HB minus HA. So then I guess we can multiply this by 2G, and then we can take the square root, right? So we'd have VA would then, we'll divide it by this term and multiply it by that term, the square root. So we'd have 2G times HB minus HA divided by 1 minus dA to the fourth over dB to the fourth, and square root of all that. Let's make sure that we see this comes all the way down, right? All this under the square root. And then, of course, if we wanted to get Q, right, that would be just VA times AA. Go up here, where is our cross section, right? So the cross section says 250 millimeters. So what would we get? We would get, for our area, we get pi over 4 dA squared, and then times this big square root here, 2G HB minus HA divided by 1 minus dA to the fourth over dB to the fourth square root. And I think now these are all, everything in here is known. So we can pull that in. We can all just calculate that out. So that would be pi over 4 times dA. Let's see what dA is. A is over here, so our diameter at A is 250 millimeters. So it'd be 0.25 meters squared. That's before, and then 2 times 981 meter per second squared, and then our readings from the piezometers, HB was 950 and 250. So it'd be 0.95 meters, 0.25 meters, and all this divided by 1 minus, let's check again here, at dA it's 250 and the other one's 0.4. So we'd have 0. Well, I guess we can just 0.25 meter to the fourth divided by 0.4 meter to the fourth. Of course, we could pull those together. That's what I was just thinking, but we'll leave it as it is. So if we do all that, then my calculator gives me 0.197616 cubic meters per second, or if we round this, 0.198 cubic meters per second. Right, so that would be our result. So based on our setup here and the readings that we have in our piezometers, we can now say what the flow rate is, right? About 0.2 cubic meters per second are going through this pipe.